Hello everybody, we're getting ready to do 5.4, completing the square for SAT Math Level 1 prep course here. Email me here for materials for PowerPoint so you can go through at your own speed and take notes using your note-taking guide or worksheet. 5.4, completing the square. We got 40 points here that would go into your note-taking guide, and then a 44-point skill sheet at the end of this lesson, which is not included in this overview. This section explains how to complete the square and shows how it can be used to solve quadratic equations, including those you solve by factoring. How to complete the square, sometimes useful to complete the square within a quadratic expression, so that it includes the square of a binomial. To complete the square of a quadratic trinomial to form a x squared plus a bx plus c, add and then subtract b over 2 squared, b over 2 squared. To complete the square within x squared plus 10x plus 7, add and then subtract 10 over 2 squared equals 25. So the way you would do that is you would x squared plus 10x plus 25 plus 7 minus 25. This is your perfect square now. X plus 5 squared minus 18. So this would be negative 25 plus 7. To complete the square, quadratic expression having to form ax squared plus bx plus c. First, factor out the a from the variable terms. So we're going to factor out a in this expression here. And then 2 times x squared minus 6x plus 9. This is 6 over 2 squared plus 5 minus 18. So this would be something that you add out here because you're adding 18 here. You have to subtract it outside here. So this becomes 2 times x minus 3 squared minus 13. Since 2 times 9 is being added to complete the square, 18 also needs to be subtracted. So they explain that there to produce an equivalent expression. Solving non-factorable quadratic equations. Any equation, including those that are not factorable, can be solved by putting them in the form x plus b squared equals k, and then taking the square root of both sides of the equation. To solve x squared minus ax plus 9 equals completing the square, rewrite the equation like this, so that only terms involving x are on one side of the equation. Complete the square by adding negative 8 over 2 squared. Negative 8 over 2 squared equals 16 to both sides of the equation. So now we have a perfect square here, and then over here we have that. X squared minus ax plus 16 equals 7. X minus 4 squared 7. Take the square root of both sides. So we have this. X minus 4 equals plus square root of 7. X minus 4 equals the negative square root of 7. X equals 4 plus square root of 7, or x equals 4 square root of 7. Solving a quadratic equation by completing the square. Solve quadratic by completing the square. Rewrite the quadratic equation in a form of x squared plus bx equals k. Add the number that completes the square to both sides of the equation. Take the square root of both sides of the equation and for x. So the quadratic formula, if you need to find the solutions to the equation, quadratic formula could be a way for you. Here it is here. Since quadratic formula is not included in SAT Math, in the SAT formula reference sheet, you should memorize it. Negative b plus or minus radical b squared minus 4ac all over 2. You should memorize it. The quantity underneath the radical sign is called a discriminant. The discriminant is a part of the quadratic formula that determines whether the solutions are real or not real, equal or unequal, rational or irrational. If it's less than 0, the solutions are imaginary. Equals 0, the solutions are real, equal, and rational. If it's greater than 0, the solutions are real and unequal. If b squared minus 4ac is perfect squared, then the solutions are rational. Otherwise, the solutions are So here is an example here. Since quadratic formula is not factorable, solve either completing the square or by using the quadratic formula. Method 1, rewrite the equation like that. Completing the square. So we're going to add 6 over 2 squared to both sides of the equation. We have this here, so y plus 3, we're going to add 9 here. This is perfect square. And then on this side here, we have positive 2. Take square root of both sides. We come up with this. And then we solve for y, we come up with this here. Negative 3 plus radical 2, minus 3 minus radical 2. Solve using a quadratic formula. So we're going to plug these values into our quadratic formula here. We get this situation. What does that amount to? We do the further arithmetic there, and we get negative 6 plus or minus square root of 8 over 2, which produces this. And then we can factor negative 3 plus or minus square root. It's the way to do it with a quadratic formula. By completing the square, transpose the constant term negative 3 to the right side of the equation. I'm going to get rid of that negative 3 and factor out the 4 from the left side. So we have this here. So now we're going to complete the square by adding negative 2 over 2 squared. Since this is being multiplied by 4, 4 times 1 to the right side of the equation. So we have this here. Here's our perfect square. And then 4 times 1 would be 4 here. You got to add 4 to the other side as well. So we come up x minus 1 squared equals 7 over 4, because we divide through by 4 here. And solving for x by taking the square root of both sides of the equation, we come up with this here. We're going to take the square root of both sides now. Square root of 4 is 2. Or x minus 1 equals the negative of square root of 7 over 2. And then when we do our addition, we come up with this. X equals 1 plus, and then x equals 1 minus square root of 7 over 2. What is the smallest integral value of k for which the roots are real of that quadratic? Here are possibilities here. The roots of the quadratic are real when the discriminant is greater than or equal to 0. If this equals 0, then a equals 3, b equals 8, and c equals a negative k. So we would have b squared minus 4ac is greater than or equal to 0. So we have 8 squared minus 4 times 3 minus k is greater than or equal to 0. So 64 plus 12k is greater than or equal to 0. 12k is greater than or equal to negative 64. And we do our algebra here, and we have k is greater than or equal to negative 5 and 1/3. So we go down here, and we look at our choices there, and we come up with negative 5. It would fit that. Sum and product of roots. Quick way of finding the sum or product of solutions to a quadratic equation without actually solving the equation is to use these formulas. Sum and product of roots formulas, ax squared plus bx plus c equals 0. Then the sum of the two roots, negative b over a, and the two roots c over a. By what amount does the product of the solutions of 3x squared minus 10x plus 13 equal a exceed the sum of its solutions? The sum of its solutions here would be negative b over a, be negative 10 over a equals 10 over 3. Product of the solutions would be c over a, which would be 13 over 3. The product of the solutions exceeds their sum by 13 over 3 minus 10 over 3 equals 1. So that would be another way of solving quadratics. Email me here for the PowerPoint and the worksheet and a note-taking guide, as well as solution PowerPoints for the skill check at the end of that lesson. Thank you very much.